Hey, hello everyone, welcome to this presentation. I am Safa and with my four teammates, Aliza, Zaki, Faisal, and Rashid, we will present our project on real-time analytics and big data, an implementation of AWS. This presentation is our collaboration as a team in the Big Data Infrastructure and Technology course, where we aim to explore the fascinating world of big data and its application. Okay, so what I said before, in our project, we choose to implement our solution on the AWS because AWS provides a highly scalable and cost-effective infrastructure for big data processing, storage, and analytics, making it an ideal choice for several companies. So basically, in the real world, companies often have a lot of data, right? This data can come from different sources like customer transaction, social media posts, or sensor readings. It can be really hard to make sense all of this data. It takes a lot of time and effort to process it. And of course, we need to have the right tools and expertise to handle this. Okay, next. And then from the background that I said before, finally, we aim to create an AWS architecture that implements cloud in the field of data analysis for several companies that need data analysis for their needs in, of course, their companies. Our AWS architecture is designed to make it easier for companies to process and analyze their data. It uses cloud computing to provide a scalable and reliable platform for data processing, and it also includes a comprehensive set of AWS services that can be used for data processing, transformation, warehousing, querying, and also visualization. So with this architecture, companies can overcome the limitations of traditional data processing method, improve scalability, and derive valuable insight from their data more efficiently.
Okay, so this is the design of our architecture. As we can see on the screen, all the AWS services are within a VPC. We place all the services in a VPC to enhance the security of the architecture. Going back to the background that has been explained by Safa before, we create this architecture as a cloud implementation of data analysis, where Lambda is used as a serverless cluster, the AWS Glue for extract, transform, load, process, data processing using Amazon Kinesis and Amazon EMR, data warehousing using Redshift or DynamoDB, data querying using Athena, data transformation using AWS Glue, data visualization using QuickSight, and monitoring using CloudWatch. Next. For more details, we will explain the function of each service one by one. First is the AWS Lambda. AWS Lambda is used to manage API requests from application or website with the purpose of fetching data resource. When an API call is made, Lambda will activate an extract, transform, and load process, or we can say it as ETL.
And before we process the data, we use AWS Glue. AWS Glue is used to perform the extract, transfer, and load. And Glue will read the data from the data source, transform it according to the specified business logic or requirement, and load it into the data warehouse. And then next we come into the processing process. We use Amazon Kinesis and Amazon EMR. Amazon Kinesis is used to collect and process real-time data, and Amazon Kinesis also can be used to collect data from sensors, devices, or application in real time. And then we use the EMR. The data processed from Kinesis can be sent to EMR for more complex data analysis and batch processing. And then for data warehousing, we use Redshift and DynamoDB. The processed data from EMR can be stored in Redshift and DynamoDB. Redshift is a good choice for storing data for analytical purposes because Redshift is very efficient at querying large dataset. And DynamoDB is a good choice for storing data for real-time application because DynamoDB is designed to be very fast at accessing data.
Okay, the next is data querying with Amazon Athena. Okay, Amazon Athena is a service that allows you to run interactively SQL queries on data stored in S3, Redshift, and other data sources. With Athena, it's a good choice for running ad hoc queries on large data set. And we can make a query raw data in encrypted data on S3-based data lakes, and we can access Athena from AWS Management Console, API, Open Database Connectivity, or Java Database Connectivity driver for programmatic access. Next. The next is data transformation with Glue. AWS Glue is also used to transform data for visualization, and Glue can be used to create data marts, data cubes that are optimized for visualization. And with AWS Glue, we can it's a serverless data integration service which can simplify for discover, prepare, more, move, and integrate data for multiple sources for analytics, machine learning, and application development. And with AWS Glue, we can simplify ETL pipeline development, discover data efficiency, and interactively explore experiment on data processing and support various processing frameworks and workload. Next. Okay, next is data visualization with Quick Insight. Proceed and perform data can be visualized through Quick Insight. With Quick Insight is a service with that used to visualize data, and we can use to create dashboard and report that are used to track the performance of the business.
Next, monitoring using CloudWatch. Throughout the entire process, CloudWatch is used to monitor and manage the performance of the infrastructure and application. This includes collecting metrics logs and even from AWS service, getting alarm to notify potential problem and taking automated action to mitigate the problem. CloudWatch also provides insight into the performance of the application. It helps in identifying and fix bottlenecks. Next. So there's a question, how can user and developer interact with the architecture? So developer or user can access the architecture through CloudWatch and QuickSight. CloudWatch can be used to monitor the performance of the architecture, and QuickSight can be used to visualize and analyze the process data of creating informative dashboard and report. Next. Thank you.